Let's begin. So to quickly cover some of the useful tools I provide for the user, first off, we have the colors namespace, which is from our 370 class, which is just a bunch of constant vectors to provide different colors for the user to use. The math tools is also a namespace. This is where we have the p-sphere to p-sphere collision, as well as the values for computing projections and perpendiculars, and clamping values alongside that. So where's the math tools CPP file? So for the CPP file, b-sphere to b-sphere, we get the two b-spheres, center and radius, get the vector between the centers, add the radii together. If the dot product of the vector from the centers is less than the radii squared, that means we got a collision. Projection constant, excuse me, this is the v dot w divided by the w dot w. This is useful for trying to figure out if something is to the left or right of a vector. Beyond that, we have the projection over here, which takes that constant and multiplies it by w. And then the perpendicular takes the v minus the projection. For clamping values, the user passes in a value, as well as a minimum and maximum threshold. If it's less than the minimum, it becomes the minimum. If it's greater than the maximum, it becomes the maximum. Otherwise, nothing happens. Clamping the vector, we do the same thing, except now we extract the x, y, z, and w's for all of them. We call clamp value on each of them based on the x, y, z, w's of the given vectors, and then we reconstruct the vector for the input. For the time, we got the attorney for pass-throughs to the kitchen. And as a refresher, the kitchen also has pass-through to the time singleton and the freeze time. These are the only ways that the engine time can be directly called. Anything beyond that has to go through the time singleton. For the time singleton itself, let's go to the header. So here's the header. We got to get the game time and the frame time, as well as all the private attorney pass-through functions, and then we're getting the time and the frame time. So for the thing itself, we have a wake-up call. This wake-up call is done in the load resources once the user has defined everything. At that point, we'll start keeping track of the game's time. So that's what we set the current time to be. In the processing of time, we will be doing the getting the previous time and then computing the current frame time using the freeze time class. This makes sure that the current time is not being affected by us using the freeze frame tool. And then we also compute the frame time. Got getters and then the unload. Freeze time, I'm using the dynamic freeze time file that you gave us. And so here's the getting the refresh rate. Other than that, it is what we already know about, where if the frame time computed is beyond what our threshold is, we assume time is frozen. So we don't update the current time because time is frozen. We can't update the current time. And then we have our hacked key releases that we're waiting for. So if I were to run this really quick, we can see that we got our total time going. If I press F10, we can see that all of that is done. If I press F9 to do a frame by frame, we see that how it's changing how long it's frozen. So if I talk for a bit longer and wait for a moment and then press this again, we can see we have a longer frame time frozen. Then if I unpause it, we can see that everything is going back to normal. And if I were to swap scenes, we can see that we have the same thing going on. You can pause it, frame by frame it, continue it. If I were to freeze frame and try to swap scenes, that works as well. As you see, and then closing that out with no leaks. And that's it.